I'm back, and now what we want to do is add two waves, both constructively and destructively. So how is that going to happen? We need to have two identical waves, same amplitude, and they're going to be the same wavelength, and we're going to add them together such that when one of the waves is at its maximum, like this, then the other wave is going to be at its maximum. So that's going to be constructive interference. But if you're going to add, let's say, to this one, if you added a wave that was the reverse of the one that you got, so when this one is at its maximum, this one's at its minimum, then you're going to have destructive interference. So how can this happen? Okay, first let's look at adding together two waves that are going to be identical. So notice that in that first column they're blue. Okay, so that means that their particular wavelength, their particular frequency corresponds to the color blue. And now the frequency is going to be controlled by how wide it is. So that if you've got a large wavelength, so lambda is large, then the frequency is going to be small. If on the other hand you got a wave that is, let me put it over here, that's more like this, okay, there's the wavelength is small, but the frequency is going to be large. So we can control the frequency of the light by picking the color of the light that we're interested in. And so that blue one there represents a particular frequency. Also notice it's the same height as the one that is above it there. So we're going to be adding together two waves, same frequency, and also they're going to be the same amplitude. Alright, so how could we add those two waves together so it's going to be constructive? So imagine that you've got a flashlight. So you're going to take the flashlight and you're going to shine it on the wall from a certain distance away from the wall. And so when the light comes out of the flashlight, it's going to start at a certain position. So maybe it starts like this, and then it goes and it hits the wall. Okay, now if you take the flashlight and you move it closer, could you imagine a situation in which the light that comes out of the flashlight for this distance, by the time it gets to the wall, it's in phase with the other flashlight? So you've got one flashlight that's close to the wall, another flashlight's back here, and they're both sending their light to the wall, and they both, when the light gets to the wall, they happen to be in phase. And so that's going to be constructive interference. But could you also imagine a situation in which you got one flashlight and it's shining a light into the wall, and another flashlight, and you adjust the distance on this flashlight so its light, when it reaches the wall, is out of phase? So you see in the bottom picture on the left, it shows that when one of the waves is going up, the other wave is going down, and so when you put the two together, you get destructive interference. So that's one way of generating constructive and destructive interference, is by varying the distance that the light has to travel. Okay, the second one, this time, notice it's the same amplitude, but now it's a different frequency. So the blue, let's say, is this one here. So the red one, okay, think about the wavelength, Roy G. Biv, and the wavelengths that goes with it. Red has a larger wavelength than what blue does. So you'll notice that when I drew the red one, I made sure that it was like this. So it has a larger wavelength than what the blue one does up here. So could you imagine if you had two flashlights, and one of them is going to be a blue flashlight and the other one's going to be a red one, and the distance between the flashlight and the wall is going to be identical in both cases, but the difference is going to be the wavelength. So can you imagine that when the blue one gets to the wall, it's going up, and the red one, when it gets to the wall, is also going up? So when you add the two together, you get constructive interference. Now look at the picture. So it's on the bottom row, second picture there. This time we're adding the color blue and the color green. So where is green at? So green is going to have a wavelength larger than blue, but it's going to be smaller than red. And I tried to draw it that way. So the green one is going to have a wavelength that's different than the wavelength of red. You're going to take your two flashlights, so you get the blue one and then the green one, shine them on the wall, same distance this time, but notice this time the green one, because of the difference in its wavelength, is going down while the blue one's going up. So that's going to be destructive interference. Okay, there is a third way of making constructive and destructive interference. So this time I'm going to use the same color of light, so the same wavelength. I'm going to also notice it has the same amplitude, but now what I'm going to do is take my flashlight and shine it onto a mirror so that some of the light is going to bounce off of, well, let's say it's a piece of glass. So we have a situation like this where you have, this is a mirror down here. This is the surface of some glass. So light is going to come down. Some of the light is going to bounce off the glass and go into your eye. And some of the light is going to bounce off the mirror down here and then go into your eye. Okay, so that the wave is going to have two different routes to get to your eye, either bouncing directly off the piece of glass, going into your eye, or bouncing off this mirror down here and then going into your eye. The difference is going to be the angle. So in one case, I'll take the flashlight like this, and the light will go down, bounce off, go into my eye. In the second example, I take my flashlight and it's at a different angle. So because it's at a different angle, that means the light is traveling a different distance. And we know from the first column that if light travels a different distance, it could end up either being constructive or destructive. Pretty cool, huh? I hope so. So this is 3 different ways of making constructive or destructive interference. And so we're going to take a break, and when we come back, we're going to talk about the double slit method of producing interference.